3.
Okay. Okay, thanks, man. Okay, check out your notes. You continue with energy changes.
Right here.
Come, Zayden, tell me. Zayden, what is exothermic?
Heat released by photovoltaic reaction.
Good. What happens to the temperature?
Temperature increases.
Okay, that is all. All right, once you see temperature increases, exothermic. Don't think anymore. Zayden, give me a few examples of exothermic reactions.
Neutralization, increasing elimination, and acid plasma.
Okay, just remember at least those few. In case anyone asks, how about redox? Depends. Redox can be either. Okay, so there's no general rule for redox reaction. Mingting still flipping? Oh, okay. Mingting, if I just dump this curve to you, this energy curve to you, exo endo. Good. Obviously, an endo curve will look like this. Okay. Oh, sorry, I make sure I did. Recognize the curve. I don't even need to give you the axis. Recognize the curves. Making bond breaking, exo or endo.
Yeah.
Bond breaking is endo.
Bond forming is exo. So remember that. Yes, remember that. And for you, always remember every single chemical reaction involves bond breaking first, followed by bond forming or bond making. Okay. Now, let me see. Mingting, what is meant by activation energy? Okay, good. Now, if I look at these two curves, what is delta H Mingting?
Yeah. Is it? No, at the bottom.
No, delta H is always between the final and the initial. So this is initial. This is final. Mingting, make sure you recognize as this two. This is delta H. Okay. Notice my arrow is always from initial to final. Delta H. Mingting, this curve, delta H, positive or negative? Okay, hold on. Exo endo. Exo, delta H, positive or negative? Yes, exo is always negative. Can try to remember that. Seriously, you have to remember that. There's no choice. Endo is of course always positive. Zayden, for you, this few concepts will not come up. Okay. Now, what else do I need to tell you? Any questions about energy changes? I think to me, energy change is quite simple. Yeah, it's memorizing part. But can you, I think I've given you this last week. Take note, thermal decomposition. It has come up quite a few times in the past 5 years. So it's always endothermic, thermal decomposition. Okay, what else do I need to elaborate? I think the rest should be fine. Okay, one last thing that I haven't had time to go through last week. Let me see. Today 16. Okay, this part. Now, this is a fuel cell. Zayden, just bear with me for a while. Just go through this, even though this is not likely to come up for you. All right, this is what they call hydrogen fuel cell. Now, essentially, hydrogen goes in, H2 gas flows in here. So basically, your H2 becomes hydrogen ions.
Yes.
And in the process, electrons are given out. Okay, so where does this happen? Here. This part. Okay, it happens in here, this part. This part here. And the electrons will exit from here. But that's not the end, right? Because your H plus will move across the electrolyte. Actually, this is the electrolyte, this one. And once the H plus reaches here, it will combine with O2, and the electrons will also enter here, and all together you get something like this. So this part, your H plus, actually 4 H plus. Okay, plus 4 electrons, plus a molecule of oxygen, and that gives you water. Okay, so oxygen goes in here, water comes out there. Okay, Ken Ming King, this sometimes comes up for you, hydrogen fuel cell. To make a long story short, essentially, this is the overall equation. It's exactly like combustion of H2O, or H2, I mean. Zayden, take note of this formula, this equation. This can come up for you definitely, combustion of H2. But except there's no actual burning going on. Instead, it goes through an electrochemical process. Electrons leave here and returns here. Oh, by the way, what's this? This is basically a resistance. Right? In US, they don't use this resistor symbol. All right, they use this symbol. Okay, so essentially, this electrons form a current, and the current is to do some useful work. Okay, I'm not going to go through too much of this. Just keep in mind, hydrogen fuel cell, overall, this is the reaction. Just that it's not burn, it's not a combustion, it's an electrochemical process. Okay, that's all I want to mention about this. Now, let me pass you your worksheets.
Square, this one square like honestly. You do it because like easier. Other than something other than in this case, right, what to do is have to show me the what is the question? It doesn't want to. Oh, yeah. In this case, what's very one is because 2 months to divide on it. The first thing not quite good in the economy. Sometimes it doesn't fit right. I want to look for other experiences to divide for them before you fit the identity.
Zayden, you can
But now you can change it.
ignore these few questions.
Now something the what? Something the what? Yeah, that's looking at the people about using the operator line.
Photosynthesis a chemical reaction, right?
It is considered a chemical reaction, yes.
Yeah, it be right?
Chemical reaction.
It's a problem.
And
Square x e square.
process.
So 16 can go like that's not right.
Don't forget physical processes also, right?
Right. Yeah. Right. Right. Or x minus.
Zayden, you can strike off this one as number 4. Inside.
That's all I'm asking. I think you said, yeah.
You said, but you see me halfway on the open.
It's yeah.
Yeah. I'll be very fast with the phone.
It'll be long.
Okay, actually, it's neurotonic when total energy absorbed from bond breaking is more than total energy released from bond making.
Okay, better know the answer to this, huh?
You want to try yourself, you want to do it.
It's true, right?
Bond breaking means endo, right? Endo means positive, right? Then bond making is exo, meaning negative, right? But the first statement, I mean, the first part says that a reaction is endothermic. It means that overall is positive, right? So that means the positive part is greater than the negative part. Okay, yeah.
Okay. Why reaction not energy? All reaction needs activation energy in order to get started. Correct, right?
Reactions are physical processes, no?
In a hydrogen oxygen fuel cell, oxygen is oxidized to form OH minus ions at the positive electrode. No, right?
No, did I mention OH
No,
minus?
that's not
No, right.
Endothermic.
It's either that you can strike all these two as well, 5 and 6. Okay, 7 as well. I don't think it's quite rare. Once in a while, maybe, but quite rare. What are you doing?
Plus, oxygen means it's combustion anyway.
Not all the time. No. Oxygen, it can just simply mean a normal oxidation process. Not all the time. Not all the time. Yeah, probably.
So,
Probably.
so it's wrong. Bye. I believe if 3-1 and anything wrong, we should except why. What's the answer for question 1?
Question 1. I thought you are very confident already.
No.
Never mind, I'll tell you. Should I say don't need to travel through?
Exothermic.
It is something circle, it's right? It's not just a small circle. It's not the big one is twice the small one. To that equation. Yeah, yeah.
Solid to changing state. From solid to aqueous means it's melting.
No, solid to liquid is melting. Solid to aqueous is not melting. What is it?
It is.
Both of you better know. Solid to aqueous.
It's not. It's like.
Yeah.
Okay.
Solid to liquid is melting. Solid to aqueous is. No, you need to know. You really need to know. Solid to aqueous state. What process is that? Actually, it's here. If you're referring question 2, let's say this one, number 3. Solid to aqueous. What kind of process is this? Obviously, it's a physical process because there's no change to the substance. What is it? Zayden, can you remember? Solid to aqueous. It is? Yes, dissolution. Anything you better remember this.
Solid to liquid is melting.
Yes.
Liquid to gas. Boiling.
Or evaporation.
So it's endo.
Yes.
Just you find things that
Correct.
like this kind of constraints in there.
And a
You'll find the balance. You will try bigger versus smaller, which one faster, which one slower, which one that time, which one more time. You contract that with your own multiplication or addition. And present simplify. You should be at the 3B. Should answer.
Okay, Zayden, one more, you can strike off B, but you still need to do one A. And also the whole of question 2 under section B. This one you can strike off as well. In section C, you need to do.
H2 to H2 is what?
H2. Wow, okay, this one is not so easy. Even though not for him, but hard to say. H2 to 2H. That one is look at the state. Any change in state? No. So essentially this is H, right? H2, right? And then they become two separate H atoms. So in other words, this is actually bond breaking only. Only bond breaking. Nothing else. That one can come up for you.
Bond breaking.
Only bond breaking.
This is redox.
Which one is redox?
4.
4? Is it redox?
Any redox? No.
You better be able to answer it.
Yeah, it is redox.
Yeah, it is.
So I don't know.
But redox can be either one, right? So
Yeah.
that doesn't mean anything.
I saw it equals cancellation.
Oh, there's one thing I didn't tell you last week. Come, both of you, can you just go back to last week notes? There's one part that I think I missed out. Go to this exodermic. I give you a few examples, right? Combustion, neutralization, respiration. This is from last week. Freezing, condensation, acid plus matter. But I want you to add one more. Okay. Oh, you need to know also, Zayden. One more example is acid, not acid, matter plus water, cold water. Provided the matter can react with water. Add this into. And this is exodermic. Provided the matter can react.
As hydrogen is added that occurs so they have to enter in excess. So this is neutralization. Exo. We're actually something else not to use external.
Ask me.
Well, this one. How would I water?
Which one is number 3?
Number 4.
Okay, better write down somewhere for you, I'm meeting. Come. This amount, notice there's a unit here, kilojoules. So take note, delta H in kilojoules. Exo endo. Yep. Now here I have 2 moles of this reacting with 1 mole of this. Okay. But if I change the ratio, 1 mole of this reacting with half mole of this, it's still the same reaction, correct? Then the delta H is, what do you think? No, it'll be half. Because you only have half the amount of reactants, so half the amount of heat. but I'm not done yet. Now, this is a reversible reaction. If I flip it over, delta H is reversed as well. Now it becomes an endo reaction with the same value. If you're listening to this, better highlight this. This can come up for you.
So there's no option. You're not finished.
There's the next page, right? Oh, okay. That means there is this cut off. It's cut off. Okay, let me see the original. I don't know whether I still the original. Oh, you know what they asked, right? I think let's see whether I still the original.
What do you think you we could take this? Good question. Okay, just this that's out of just to figure this out there. But that's access to it. What is it like? Like you could components on red line, so you can add those of the conferences, you could sit in that. It's a right track, it's the side, yeah, you're not getting the object, but you find something. You find the conference one, and go back together, what you see the bank. What is the yeah, you take under you 5 minutes. Oh, you get up to so many square. Wow. You say expense playing the video. That's what you're looking for. What I do? We can figure out this. Oh, gee. I don't know.
I thought this. The other options are false. Yeah, both are positive. But I'll follow the original. So the C answer is positive 98.5.
Oh,
What's it?
Oh, then it's okay now. As long as you understand.
yeah. B minus Q. P. I don't need. You cross, you remove method Y. There's no remove equation. Some combination over. No multiplication. You got 2P minus 5P. That's 4P plus 12Q.
What job? I told him not to do anything.
What?
You just cancel the whole thing for him.
Which whole thing?
MCQ.
No, only 3 questions were cancelled. Yeah, but structural questions still quite. No, basically for combined, this topic is really small. It's really small, so try to get full marks of it.
Please.
I don't know which one.
So, activation energy is reacted at right.
Section C, question 1, right? The
Yep.
graph is
The graph is.
so turning.
I don't know.
Now, what happens to the temperature? Yep. So the key is once you see a temperature increase, then you're pretty sure there's an exothermic process going on. Okay? But of course, you have to answer how come the temperature decreases? Think a bit about that. Why does the temperature go down?
Activation energy is Y, and then the energy in the start direction is Y. So technically, they are both the same thing. And if you get asked for cannot, obviously both of them are wrong.
Oh, which one?
Because they mean the same thing.
This again?
It's so
7,
stupid.
6.
I don't know.
Oh, why?
Activation energy is Y. Then if it's correct that the field will be correct, right? The energy in the direction is what? Y energy. They're the same thing.
Yeah. So obviously both are wrong.
Yeah. Produce used to produce heat energy. Hydrogen is burnt to form steam.
Okay. Steam. Did I use the word steam? I don't think so, right? What did I, what?
Oh, it's A.
Keep this in mind. This doesn't come out of the plan, but it can come out.
Instant car cooler, fans, compact maker, internal and water use, spray instant car. Explain how instant car works.
And
Mm.
there's excess link on
There is access. What? You're on the right track, but it will be better if you express your answer differently. Okay, since it's in excess, what is limiting? Yes. And what has happened to copper 2 sulfate? It undergoes a reaction with zinc, correct? But eventually, what happens to copper 2 sulfate? Oh, section C.
So fast?
Yeah, it is pretty fast. No. Azita, can you remember the idea of limiting reactant? What happens to the limiting reactant? Yeah, eventually it
Zero.
zero. Limiting reactant means it's used up, and that means the reaction stops. And remember, what's the temperature of the surrounding? It's still room temperature, right? Or whatever it is. So therefore, it still has to cool down. Yeah.
Then the temperature just goes back to
Room temperature.
And
If you want to add by the various heat transfer mechanism, no need, I mean, joking, no need to add.
undergoes endothermic reaction process. What reaction?
You stay at 1A.
Yeah, exactly. I just started on it.
Okay, that's fine. Better get 1A correct. That's a primary school question. Sure. They ask this in PSLE all the time.
Oh shoot! Oh my gosh, it's really hahaha.
with the last part of 26 now.
That's all, but this is the question.
This is the surrounding, right? To be right,
What is released to surrounding
heat energy.
And there's no way
for 1A or 1B?
practicing enough, right? First you get
1A?
100 hours.
No?
The temperature drops rapidly. How can heat be released to the surroundings?
Yeah, so it's correct, so it's absorbed.
Yeah. That goes from 2 marks or 3 marks.
You understand the fundamental questions. Then you can do any type of question. You want you to just memorize about life. That's how the leadership. You have much to listen to. Equation. Right. Yeah, how to that.
I didn't do it.
Lazy time or lazy at the TV.
He's waiting.
Alright.
Here at the different programs.
You think of better things I know we're talking about. What are you talking about? Doesn't go my way, you can talk to everybody, we just.
Okay. Almost. Okay. Yeah. Energy pushed. Oh my god. Am I supposed to know how to do
Which one?
1D? Am I supposed to know how to
1B,
do it?
1D.
Am I supposed to-
Yes, why not? Yes, find the moles. No, this one, the equation given here is for 1 mole, right? So find out how many moles this is, and then proportionate accordingly.
0.2 more.
Yeah.
5 times 0.2 more.
And 0.2, and you get an answer.
184 times 0.2.
Make sure your minus is still there. Then you're going to lose at least half mark. Make sure your units are correct.
8. Then minus.
Square. Anyhow, we go in.
Water is which is greater amount of energy? Water or the mixture of hydrogen and oxygen? This one is what? Hydrogen burns in the air. So this one is an exo, right?
Oh yes, you better recognize it's an exo.
So
And as I really right, like pushing.
it's minus. So products less energy, right?
You better be sure. Is it like I forgot something? Actually, 2A for you can come up. So yeah, try out 2A as well.
Yeah, actors have more energy, I'm correct. Okay. So water lah. No, I mean
Oh, there goes your marks also.
it's a mixture of hydrogen and oxygen. Mixture hydrogen and oxygen. Yes.
Tại còn cái gì cái nào?
Is exotonic reaction. Heat energy
Yeah, go on.
Yeah.
is
Actually,
released, right,
Yeah.
to the surrounding.
This is 2 pi times this plus 2 pi times this. These are multiplied.
So
You take out 2 pi from over there, 2
reactants
pi outside. Then what you get?
would have
This one plus this one.
higher
So
energy.
this one mistake. One. Second mistake, you 4, 16, you cancel very happy or not 16 minus 4.
Compared
It's 16 divided by 4. One. Two mistake. Third mistake, you pi cancel, this one pi come back out.
over water.
Yeah, 3 mistakes. So 10 minutes. Total 10 mistakes. And you get this whole thing wrong. Okay, this whole this line will be wrong.
Draw a labeled energy profile diagram.
You do the old version.
Energy profile diagram.
Which is the energy diagram as well. Yeah, so make sure you recognize the word. It's the same as your energy diagram. That one, either like that, like that.
Diagram.
That one.
Shit. Okay.
And label them. Almost 100% they want you to label. Don't be careless, huh? Don't draw the opposite, huh?
I'm
Yeah.
Right.
seconds.
No, don't put anything. Did they?
After this question.
Did they put seconds? Where?
Afternoon session, section C.
Oh, okay, but you don't have to follow it.
Get that done. Yeah. Okay, this what's H? Change in temperature. Temperature.
H is not temperature.
H is change in temperature.
H is enthalpy. Enthalpy is energy level.
So I just put H.
Just put H. That's the safest. Of course, you can spell it out loud, but make sure it doesn't spell wrong.
Okay. Let's draw straight line.
Straight line. By right, there should be some more space because you have to write some things here and write something here on the straight line.
I lazy draw. So I write reactants. Don't you write the reactants they give me or I write reactants?
Actually, if you want to be safe, I don't know how fussy your teacher is. If they're fussy, you need to write this whole thing. 2H2 plus O2, including the stick symbols if they're fussy, no? Whatever they give you, even including the 2 coefficient 2.
That's right. That's right. 2H2O.
Yeah, liquid, if you want to be safe.
Okay. Write the activation energy all this.
Yup. Label the activation energy, label the delta H.
Can't you draw the arrow also?
Yes.
Activation. Label.
Yes, label.
Activation energy.
After
After I draw the piece. So it's not straight. It's straight. Okay. Then from here to here, decrease. So this one is.
Yeah, job done, isn't it? Easy marks. As long as you don't draw the wrong version. For one thing, some teachers are very fussy because they give you the value, they should write delta H equals blah 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 blah. I don't know how your school, maybe you can try your luck.
Two moles of water is what is the energy to break the point of 2 moles of oxygen? Is it not the same thing?
No.
Is it the MCQ that we did?
Is it what?
Is it the MCQ we did?
Not exactly, not exactly, not exactly. This one is a very different question.
The same,
The change is still the same. Overall change is still the same.
no? Minus to plus, like minus. So it's minus. Like minus. Alright.
Which one my your section?
1852 minus.
Okay, come. You want one more formula to remember? I'll give you one more formula. Okay, come, write this in. Same for you if you're listening. Okay, one more formula, delta H for a reaction equals to delta H on breaking. Remember, always break the bonds first. Plus delta H
For bond forming.
for bond forming. But in your head, you also need to remember this value, bond breaking is always a positive value, right? Whereas this value, bond forming is always a negative value. So highlight this formula if you want to use it.
Bond breaking. Bond forming is 1852. So 1852 kilojoules plus bond breaking, right?
What is the one?
Bond breaking equals negative 484 kilojoules. And
Yes, there is a trick here. I don't know whether you realize that. Anyway, you try out first. There's a tricky part here that you need. There's a trick somewhere. Yeah, you need to be careful.
minus.
You know what is the trick? I hope you know this. Huh? Yeah. I mean, part of the. No, first thing, did you notice this value
Yeah.
is for what? Bond forming, right?
Yeah.
Bond forming is exo angle.
It's like so.
Exo, right? Exo, so therefore, if I want to convert this energy to delta H,
It's minus.
yeah, express it as minus. That is the trick. That is the trick.
Then you positive. And then for plus for 852. So it's 1368. It's a positive number. 152. Wait, it's supposed to be a positive number.
Yeah, it's supposed to be a positive number. That is to check your answer too.
6.
Try not to fall for this trick. I mean, it can happen now, which I don't like to set this out tricks. It's quite. Yeah, it's. I don't know. There's no point meaningless to trick you all at all.
You want to see us like get back to then it happy.
Yeah.
Experiment. This thing give you off. Most of the items. Now, right now.
Most, you see it everywhere. You really see it everywhere.
Without experience, I'll show you the diagram below. This is EXO.
Oh yeah, of course. I mean, just now I told you already.
Is this? It's answered it. Okay. Why is it EXO? I'm gonna explain this.
Think of it. That's not a difficult question.
Serious? Temperature decrease. Temperature increase. Yeah.
Yeah.
So
See that done already?
Almost.
Okay.
The temperature of what? The temperature increases throughout the process.
Throughout, don't be careful. I think throughout, it only increases at the beginning. Too easy, right?
The reaction mixture reaches higher than temperature of 8 degrees. Why does it decrease? Because it's going back to room temperature one. Why?
Yeah.
Because
11 seconds.
Don't say it.
Yeah, I just said it.
because copper sulfate is used up.
Yeah.
Copper.
So the reaction is done.
And
in this case, let's do P easier because I don't do base numbers. So I'll take the first one. P minus AQ. Control. Move the AQ over.
Oh.
Right. Yeah, 3 over. Okay. Equation smart. This is my and put 3P minus 7Q. Equals to 4 and 2. And start. 1, 2, 2. Right. My motion is and take all the P in my equation 2. 8Q over 3 and 7Q. 4. Now my equation only got Q. It means I can solve for Q. But if you have one equation, only one unknown, you can always have two.
Copy is a solid, right?
It's all like HQ. And that's.
Or is it a liquid?
Yeah.
What did they put here?
Q. Oh.
Look at the first sentence. 25 cm cube, 0.2 mole per dm cube, copper sulfate. So what does that tell you? It's aqueous, huh? Yeah, it's soluble. Don't forget your solubility rules.
Just look at it and I pick these one to that. If you
Six
cannot,
power,
okay, you pick anyone just pick five.
Zn.
As long as you are right.
Six power.
But I think it's on that key.
Then you get
Leave you go for the number.
it's Zn.
Jaden done. Still finishing. Done.
Not done yet, it's only Q. And then I will start
Zn is what? This one.
Q equals to 4.
Okay, remember that.
1.
Zn SO4 is
QE is equals to 8.
it is L.
You better remember your solubility rules.
It's S.
What happened to all your solubility rules?
All subjects are soluble except.
Except for what? Basic Chinese language, right?
So it's soluble lah.
Yeah.
And then what's another thing for H2? Copper. Not copper.
Mm-hmm. You should know that.
Only copper. Solid. Pure copper.
Mm-hmm.
What the one?
Yeah, what else?
Ionic equation. Cu 2 plus SO4 2 minus plus Zn. Okay.
Like I say,
Plus O plus 2 minus Cu cancel. So you get Cu 2 plus Zn plus Zn 2 plus AQ S. Complete the mass of copper. This is
mistakes, as long as we manage to catch the mistake. Worst is big one mistake, really, I tell you the mistake, you still tell me.
Oh, okay.
concentration equals mole over volume. 2 equals mole over 25 divided by 1000.
Jaden, all done. Okay. Any questions, particular questions, difficulties? Oh, which one?
The more question.
Oh, more question. Okay. On the okay, that one definitely can apply to you. Did you manage to write the equation out? I hope so.
Yes.
Yes, let me take a look.
So, mass of copper sulfate.
Okay.
Run the mass of
The difference between black and
so
understand it.
and then
Okay.
Substitution, because you're basically like splitting it back and substituting it with the other one, so you only get one underneath equation. That's why it's called substitution. Elimination, scheme substitution set. Eliminate one of the very quickly. So the requirement.
You're not too bad, no? Jaden, you got it right. But did you understand what you are doing? You do. You do. Okay, that's good. Yeah. But I just want you to add in, I mean, not say add in, but make sure you know what's going on. Because once you see this, once you see, what do you see here? Volume, right? What is this? Good. So once you see this, make sure you, in your mind, you think about this formula, mole equals to concentration volume. But it's good because you have been quite careful. Make sure your volume is in BMQ. A lot of students will forget this. Okay, so yeah, basically that's it. And of course, the mole ratio is the same. 1 mole of copper sulfate gives you 1 mole of copper. That's why you can multiply by the MR straight away, or the AR in this case.
what's the highest temperature?
Ah, good. I thought I was supposed to figure it out.
I generally like the renovation more, because subscription, I also like you can pay a lot.
10 times.
Why?
A lot more application involved.
Because
I like
the
the
more
renovation.
increased to 10 times more than the original law in the equation. So the theta h
Delta.
will increase by 10 times as well.
Did the mole increase by 10 times?
Isn't it?
Where do you see mole increase by 10 times?
Initially it was 0.005, then it becomes 0.05. Is it?
0.005, then become from.
0.05. So increase by 10 times.
How do you get 0.05?
Pick the highest temperature, which when the temperature is basically 3.25 grams.
Yep.
Then I can find the mole one.
Oh, okay, 3.25 grams of pising is 0.05. Alright, let's go through. Yeah,
Right, it's wrong.
yeah, done already, right?
What's the highest temperature?
Let's go through.
Just to minus.
That's.
You don't know, so that's all.
Never mind, we go through.
That's all.
Is it, do you manage to predict the highest temperature here? 45. How do you get 45? Guess. No way you can guess this. There's no way. 380. No way. All your water will boil off. No? How to get 380?
What's that high?
Come, both of you take note. You already seen this word, right?
Oh, it was at 0.1.
Zinc powder is in excess now. So 2.5 grams is already in excess. You go and top it up to 3.25 grams. It's still in excess. It's still 38. It's still 38.
Should I do more?
And just write 38. No? Maximum temperature is still the same. So don't get tricked. Because zinc powder is already in essence. You add some more, it won't help.
Okay.
Don't get tricked.
The highest temperature is this. The temperature remains the same.
Because blah 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 blah.
And zinc powder
Mhm.
is already in excess. It will not affect reaction.
Yeah, the reaction will still stop at 11 seconds.
But if I do this way, if it's limiting and correct, is it?
It is limiting. Technically, yes.
Really? Okay.
But there are other constraints, don't forget. Above 100, everything will boil off. Okay, done. Let's quickly go through true or false. A, Zayden. Why?
Because there are more reactions.
I think let's be specific because physical processes can also involve energy changes. Okay, not just chemical reactions, but physical processes too. Number 2 is false. Products have more energy than the reactants. Ken, Zayden, make sure you get this right. B is a common question for you as well. Yeah, so come. C. D.
True.
Y.
Why already false?
Uh-huh.
Use activation and it's the minimal energy to start the chemical reaction.
So is it release or absorb?
It's both. Like no, it's both.
Huh?
Isn't it?
Energy, activation energy is always absorbed.
Already.
Because it's always going up. There's no downward arrow. Right?
Okay.
G?
False.
Of course.
False.
Okay, great. I assume you know why, huh? Okay, so I won't go through that. Okay, number 1, Zayden. Okay, good. Of course, any questions, please ask. Number 2, okay. B, yeah. Good. guys be very familiar with all these state changes. All right. Okay, solid to aqueous, dissolving or dissolution, solid to liquid, melting, and so on. Okay, I won't go through all of them. Number 3, Zayden. Okay, good. Good. Make sure it goes down, goes back down. Number 4,
We
Ming.
already went through this.
Yeah, we've gone through, so I'm not going to repeat. 5, Ming. Good. Any questions asked? Otherwise, I shall move on. 6, Ming. Good.
I think I'm the one who did this question.
7.
A.
Yes, better get it right. Okay, look at 1A, section B. 10% ethanol, 90% water. How instant car cooler works. Zayden, what do you write for this?
I say that an endothermic reaction
Good.
is as heat absorbed.
Mm.
Then the temperature decrease, then the bonds are broken.
Bonds are broken. No. There's no bond breaking here because this is not a chemical reaction. What is that? This process. What is this process here? Ethanol and water, no chemical reaction. But what is this process?
Wait, I think.
Zayden, this one you need to know. It's a physical process. What physical process is this? Nobody knows. Come on, this is a primary school question.
Sure.
Okay, so basically the mixture evaporates. Make sure you have the word evaporates or evaporation in your answer. As now, since you're no longer in primary school, you have to add in this process is endothermic. Yeah. Your examiner want to see the word endothermic. Then you won't get full marks because you need to give the name for this process.
If I just write endothermic reaction,
You only get half the marks. And maybe you want to avoid using the word reaction, just write a process. Because by right, reaction is defined as a chemical process, which is, in this case, it's not. So heat is absorbed from the surroundings, cooling it down. Can you also try to define what is endothermic, meaning heat is absorbed from surroundings? Okay, so as I repeat, the key words will be endo and exo. You must have this, either of this word there must be correct one, of course. Make sure this there. The second keyword is the process name. Is it a neutralization? Of course, in the case it's not. If it is a state change, what state change is it? Can okay, 1B reserved for you, Ring.
Where?
What do you get?
Where?
Okay, good.
Cosine,
Get ready to do this sort of question. It comes up quite often.
Square root square comes up.
Okay, look at next one. 2A. Zayden, do you do 2A?
Square root.
So which one has a greater amount of energy?
it's a mixture.
Yes, good. Reason?
And at the end.
Because the endothermic reaction and the product of the chemical reaction must have more energy content than the reactants.
The mixture is the reactant, no? Zayden. Look carefully at the question. The mixture is the reactant side. Okay, but tell me, is this reaction exo or endo?
Endo. Exo.
Exo, do you notice the word burns? So immediately you must think that it's an exothermic reaction, which should be in your answer.
Q.
Then, of course, depending on the marks for this question, also mention heat is released.
Our power and square root is
And that implies your reactants, which is your mixture. Correct. So the reactant mixture has higher energy. or has more energy depending on how you want to write it. Zayden, fine. Okay, don't be careless about that. 2B for you, Mingting. Let me just check your diagram. Shouldn't be a problem. No harm checking again, right? Sure, all your errors are correct. Up, down. Okay, great. Full marks.
Oh, how do I see it? I can see it.
You get your answer for the 2C. 13 kilojoules. Oh, yeah. Okay, too easy. Okay, look at 1C. 1C is quite a standard question for all of you. So take note, even though the temperature drops, but make sure you realize the temperature increases initially, so it's still counted as an exothermic reaction. How do you explain your answer?
The temperature is express C 30 degrees and C from 0 seconds to 10 seconds.
Good. But I mean, there's no marks assigned here, but I would prefer you add in a bit more because exothermic means heat is given out. Remember, this is the definition for exothermic process, hence increasing the temperature from 0 to 11 seconds. Let's follow the question. Hence, look at the marks, but normally you have to write something like this: heat is given out or heat is absorbed.
Okay.
Okay, I think I've given you the answer for B already. Make sure you mention the limiting reactant. Copper sulfate has been used up, so the reaction stops. No more heat is released.
Oh, I'm asking no more heat.
I mean, depending on the number of marks. If it's, let's say, 3 marks, then you write a bit more than the usual. Okay, make sure you write something about limiting reactant. No more. Make sure you write reaction stops. And if it's 3 marks, then you add in no further heat is released.
Just like increasing.
Okay. It will return to room temperature. Okay, chemical equation. Fully, you got it correct. Zayden one is correct. Anything wrong?
Ferrous plus zinc solid. You
Good.
get zinc sulfate. Ferrous plus copper.
Plus.
Copper.
Okay, good. Okay, I don't think I need to write it out. Zayden, your one is correct. Anything? How about the ionic equation?
Cu2 plus solid plus to get zinc2 plus ferrous plus copper.
Okay, good. Zayden, correct, right? Okay, okay. So I'm not going to write that out. Mass of copper produced, I've checked Zayden already. Meeting, what's your answer? Good. 0.32 grams. Don't forget the units. Highest temperature, I think I've already mentioned.
Change.
Don't get tricked. Can Zayden? All right. Let me just. Any questions about this topic?
No.
It's not difficult, but you have to be careful.
Not.
Especially if they reverse the reaction for reversible reaction, or they change the number of moles, then you have to be careful. And that one, the minus one, don't forget, that one is very tricky. There's a minus there, which you will forget. Most people will forget. Just try out.
The C that was signed bracket, so you get.
Okay, come. Just some pieces for you.
Not the color. Exo right.
You better know by now.
Yes, exo right. How much is condensation is?
You better know.
I don't know. Like how much yeah, exo right. Yeah, got it. Okay. Formation of the cell. Wait, so ethanol plus water is what? It's evaporation.
Better know for water.
Yeah, it's evaporation.
Oh, now you have to look at the question carefully. It's not always the case. Yeah.
Oil is still
Then for this, always and the
formation of water. Formation. Okay, then. So neutralization. Also exfol. Sublimation.
You get it.
But it's not that it's from the special effect.
Right.
Aluminum chloride.
Yeah.
Aluminum oxide, so it is hydrogen oxide, H2O, water. Oh, now combustion. Write a chemical, Benz chemical equation. Okay. So ALO. AL plus, right? Yeah, I think so.
you better remember.
Is it in the particular?
Which one?
AL.
Oh yes, it is. It is. It is. You better get familiar with it. You better.
Yes, nice.
Okay, there goes the marks already.
No, it's not in the, I just suddenly remember. I didn't see, but I suddenly remember.
Okay, not bad.
I got memorized before, okay? Just I forgot.
Yeah lah, everything you memorized before. Just that you forget when the exam comes.
Foreign HF now.
HF.
Hydrogen fluoride.
Yeah, hydrogen fluoride is HF.
AL.
2C. Okay, you can skip 2C. Oh, no. Try 2C. Once in a while, it can come up for you. Did you write the chemical equation already? You did, right? So how many moles one? So 1 mole of aluminum fluoride gives out 216 kilojoules of heat. So find out how many moles is 2.8 grams of aluminum fluoride. Yeah, say that this can come up for you once in a while. It can, because there's no delta H here, so it can come out like that.
AL2O3, right?
Yes, must know that. If not, you can't form your equation.
Oh my god, I'm wrong. 6.
Oh, can.
The one mole of aluminum fluoride is from 216 is 2.8 aluminum fluoride.
Wow.
It's 12.
There's no need for anything.
So I'm supposed to find the mole.
Yes, as usual.
Nobody give me lines. Oh my gosh. I thought I had to write sentences. Do I have to?
No need.
It's
The lines are for you to write your calculations.
Right, I was talking simple, but no, it's hiding something. Okay, I think you better, okay.
Yes.
Let's see what.
Do I exhaust?
The first day, all right.
227.
We're gonna do this or not?
3 in
Then you got this like 4.
two. Why is it not a whole number? Who's wrong?
I also do 8. See, I write 8, not write 8. And then it's 3.
27.
So there are 4.
That's correct. Okay.
Yeah, this is
Heat is given off. So just do 1/6 kilojoules times the mole, right?
I think it's all. Pretty sure it's all. Yeah, but it's far. The magic, I think that she wants to do.
1, 2,
She wanted to make it, right?
5.
Right.
Q,
Which was great.
which is into 3 SF, right? 5.
I think, pretty sure social wants to do.
This reaction is going to be
Well, that's not in this. We're probably going to do the shuffling to glove. And A is equals to 3 minus
So,
and then B is equals to
aluminium
A
oxide.
minus 3. And solve anything there? Not really. Because if I use this
Glass, right?
A, B,
It's positive, so it's angle.
Then how
Oh,
about
be careless. Do you notice this thing here?
one divided?
Yeah, evolve means what?
Increase gain. Absorb.
Evolve means release. You better write it down in your English vocabulary.
Okay. Release that.
Yeah, they may use this word. They may.
Release. Okay, so release is exo.
Seriously, they can use evolve. Like a gas evolve. You better know a gas is given off.
Yes, even fine. Just in this sentence, I don't understand. S, heat, energy,
You get A minus so it's okay, no. Okay, see,
That's all?
Well, it normally to fill in the 2 marks, I will add because the reactants have more energy compared to the product.
F.
Minus 5 A squared minus 2AB plus
Compared
squared.
to the product. When you say about temperature?
Nope. They didn't mention temperature here.
Okay.
Because you know that there are some processes which you cannot detect the temperature change.
Oh, yeah.
Yeah. Like you put your water in the freezer, it's exo endo for the water to freeze. Freezing is exo, right? But can you feel the heat? No way, no way. But it's still an exo process. Okay, come, Stated, you done? Almost.
Just evolve meaning CHV.
Yes. Can you highlight somewhere? Sometimes they use the word evolve. So you better know, recognize it. The other possibility is they use a gas evolves, means a gas is given off. Oh, wrong answer.
Wrong answer.
Yeah. 2C, calculation question. Did you calculate correctly? Yeah, something is wrong. You know what's wrong or not? Go look through your calculations. Yeah.
Something not working, it's not obvious. Like region topic A equals B plus B. So this is one.
Sure.
Mm.
I think the two-seat answer is very low.
Oh, what do you get?
I was 6,000.
Oh yeah, it's very wrong. Okay, come. This, I think you understand your, let's say, one more. By the way, you better get this formula correct. What's the formula? For this question, you don't need the equation. You just need the formula. What's the formula? Aluminium fluoride. AL?
2F3.
There's no 2. It's just ALF3 because AL is 3 plus.
7.2 kilojoules.
F is minus. Yes, excellent. 7.2.
This is correct. Yeah, that's done. You need more?
Okay, let's go through together. Are you done? No, still working, right? Never mind. Just take a look.
Teacher, you can go through.
I can go through. Okay, long. I think except for the calculation, I expect you guys to get everything else correct. Only the calculation you can be a bit careless.
All wrong.
And you careless,
Oh,
you can tell your teacher I saw wrongly. Can I redo it or not? Oh. Okay, come. Boiling, Zayden.
Exo
Boiling.
or endo.
Hey, don't get this wrong. This is like 3 marks, so combustion, Zayden. Condensation. Good. Formation of water from H2 and O2. Does this look familiar? H2 and O2 give you what? Water, right? Yeah, so does this look like the burning of hydrogen gas? It does. It does. When H2 is combusted, this is the exact equation of it's exactly like combustion of H2. Try not to get this wrong. Zayden, please remember this equation. It comes up all the time, all the time. So it should be an exo because this is similar to a combustion of H2. Zayden, visualization? Yes. Now, you don't need to know sublimation, thinking sublimation. Yeah, okay, by the way, just for his info, sublimation means from?
Solid.
Yes, good. All right, so of course, it's just like boiling, it's just like melting. But say first one, don't get it. Boiling, don't get it wrong. This one also try not to get it wrong. Okay. Okay. What's the other compound? Zayden, do you get it? Yes, good. Now check your equation. I don't know because just now if you have your formulas wrong, your equation will be wrong. Check. You should get it. You should. Now. Okay with it, Zayden? Now, as Ming Ting mentioned, the answer for this is 7.2. Make sure you have your units there. You managed to get 7.2? You need to find out number of moles, huh?
What do you think about it?
Divide by ml.
No.
How many moles is that, Ming Ting? 1 over 30.
Wow.
Oh, yeah.
You multiply by the heat release and you get your answer 7.2.
Honestly, this is probably like me about hopefully after 1 hour you realize something wrong.
Okay, can. Didn't I say this kind of question can come up once in a while? Okay, lastly, better get this right. This is like a 3 mark. They always say heat is evolved. So make sure you write exo because heat is evolved. But since it's 2 marks, you can always add in the reactants. And or have more energy,
Animal collect stuff.
compared to the products to get your full 2 marks. Right, guys, any question for today?
I don't know.
No. Okay, I hope this chapter has been quite easy.
Yourself?
It's considered easy. There'll be harder chapters.
Street stars.
You just have to remember all the stuff, that's all. Huh? Oh, how can you do that? Bye-bye.
Hi, teacher.
Okay, bye.
Give all them, Give all.